So let's get started. This is a very important chapter and even straightforward. Can you hear me fine? And can you see the slides as well? Yeah.
Yeah.
Great. Okay. So it might be possible that we do a little shorter because so that there are a few key information, but it's not very long as a chapter. Okay, so what we are going to talk about is how the best way to spend our data. And in tidy models, to do that, we use the R sample model package. And this package is basically provides some functions for splitting our data randomly. And we know, so the learning objectives are understanding how to use our sample to split data into training and test sets, identify cases where stratified sampling might be useful, and understand the difference between R sample initial time split and R sample initial split, understand the trade-offs between too little training data, too little testing data, and so on. Then define a validation set when it's needed, and explain why data should be split at the independent experimental unit level. So I'm going to give some few things for as given. So as you are already, I imagine that you are already aware of few things. And so we are making a model. We have a bunch of data of real observations. And what we do when we make a model is that we want to replicate this data and see what would happen if we change something. So if we put them forward in time, if any of the predictors change values, and so on and so forth. So in order to do this, we select a response variable and the predictors useful for our model. Okay, so what else we do is, this is the very important part, because we do modeling, but we need to test our model to see how it is. If it works well, if it needs some assessments, like changing parameters, more feature engineering, and so on and so forth. So we split our original data. The main rule is in two parts. Okay, one will be the training set and one will be the test set. So the training set, as its name, it's the part that it's the part of your observations that will be used to build up the model, and so training it. While the testing set, which will be much smaller, so like 20% of the total of our data, this will be dedicated to and confined in quarantine until we found, like, so as in study model, we try different type of models, not just one. So it's good because we can test a different model. So let's imagine that we at the end select two models, and so that we will use this testing set to verify how this model works, if it's worked well or not. So as this the same if the testing set contained new data. Okay, so have you got any questions until here? Up here?
Yeah, hi, how are you?
Hi, I'm okay, thanks.
Are you showing this illustration here? Like you're talking about this illustration?
Yeah.
Okay, so I'm not familiar with SOM. This thing in the right, like near PCA.
Okay. Okay. This is okay. This is okay. I initially did this chapter, but I think someone else has added this.
Oh, okay.
But that's okay. That's okay. So this is another exploratory data analysis technique. So we have principal component analysis. We have yeah, it's most probably something else.
Okay,
So
thank
now,
you.
but
Seems
what,
to be
yeah,
seems to be the self-organizing map, which I wasn't aware of.
Okay. So yeah, now basically what we are doing is these things here. So we have our observations, and this is the response variable, so the column of the y's in real data, and those are all the other predictors. Okay, so now what we are going to do is to split this matrix of observation, the original matrix of observation into groups. One would be the training set and the other one the test set. Usually the proportion is 80-20, because you leave a very little part for testing your model, and you don't need to touch it, you need to leave it there, and you use them as a new data, basically, okay, as they were new data. And so here, what is mentioned in Madden are several different type of models that are used within our split of data. So, and it goes forward within our chapter. So we will going back to all these techniques in the following chapters. This is just to show you a nice visualization, I say, to show you how this data are split and then applied to different models, basically. But we don't, it's outside of the purpose of this chapter, basically. We are going back to this in the next following chapters. So usually, what is done is assigning 80-70% of original data to a training set, and the remaining on the testing set. And obviously, what you need to consider, let's go forward, what you need to consider is how is your data. So you first things that you do, you look at your data and make some visualization. Especially you look at the distribution of your response variable to see if, for example, in case of classifications, let's say, if the class is balanced or not, or even if in real world data, for example, if we have, we talk about this AMS data, okay, they are data from the housing. It's an housing data set, so there are a few information about these houses, where they are located, and most importantly, the price. So the of this, okay, of these houses. And so we can split our data set following a simple proportion. We use this initial split function from the R sample that you load automatically loading tidy models. So it's already embedded in there. If you don't specify the proportion, this will be 80%, or some, I'm not sure if I'm saying wrong, if it's 70 or 80%, the default option. But you know, here we specify just the proportion, and we don't add any other option. And if we see what's inside this split, we can see that the 80% of data, so it's in training set, the 20% in testing, and so this is the total observations. Then to assign this to a training set and this other one to a test, we use these other two functions, training and testing. So talking about class imbalances, for example, we might have in case of so this is members data set, but in case of we can go through this as well, but in case of the MS data, for example, some house prices can differ if they are located somewhere in more than in other places. So based on some consideration of the data and everything, we can stratify our splits, so our data, into specific, so we can stratify specifying the variable in which is generally our response variable. Okay, so to give you an idea, a bit more specific, for example, here, this is the member data set, okay, and which is something that is done from the previous course, okay, and this is Study Tuesday data. Okay, we can see that this data, so we have expeditions. Okay, I remember this. This was talking about expeditions, and so in what season, if they the gender, the citizenship, and so on, and the cause of death, if they death and injury in case they had some you know, accidents. Okay, so in this case, we want to see how many died, if they died or not, and in what percentage. So they almost all survived. But what we want to know, as we can see, that there is a very important class imbalance. Okay, because this died, for example, we can do this with factor data, such as died here is just false and true, so or yes or not, or 0 and 1, so binary data. So we can see that 98% and about 1% is very class imbalance. Okay, so one is very high and the other one is very low. So it's important what's happened if we just randomly split our data 80 and 20. Can happen that very likely that we within the 80% of training set, we have the majority of people which has false as a died. So we need to apply this stratification option to the died factor to be sure to reduce the bias and the overfitting as well, to be sure that we have the same amount, more or less, of false and true within the training and the testing set. So, and to do this, we specify the strata. What else we can, it's worth to mention. It's, I do not have much time. I'm afraid I need to mention it because sadly, I have my laptop without any power charge. So it's going to switch off. I have 32% battery and it's going to switch off itself very soon. And I cannot charge it. So I'm really sorry. I can get connected with my mobile, so I won't be able to do much. Okay, so let's go forward and say that there are some cases in where, so here is again an example. Okay, this is made by the previous course. So we basically see that now the balances of the classes changes. And to verify this, they have applied the strata and summarize, so grouping the data, and to see then after stratification, what's happened within the data. So we can see that looking at the mean and the variance of the true and false within the stratified sampling, they are quite similar. So, and then again, have you got any questions, maybe?
No, just it's a very interesting data set. I wasn't aware of it, and also the schema function is really useful. I wasn't aware of it, so
Yeah.
thank you.
Yeah, this yeah.
Sorry, go on.
Yeah, tell me.
Yeah, I agree. I found out about schema recently. I find it really useful. Another one I had kind of not used much or forgotten about was this table, janitor table, that just like allows you to have quite easily shows you the percentages and the totals. That's something I often forget about, and just wrangling those simple tables can be quite annoying sometimes. So that one's quite handy. I had one question. I noticed that it says our sample does not stratify if class imbalance is more extreme than 10%. Near the bottom of the page. Although when I go to the link, it just says we don't recommend doing less than 0.1%, I think. That just caught my eye because I think it's something that, well, in this example, we're looking at something that is more extreme than 10%, aren't we? Those that have died. And it's also quite relevant to my interest because I'm often looking at stuff with rare diseases, which are very rare. So those are quite extreme. So I'm wondering if I should be using this method.
Yeah, absolutely. You should absolutely use the certification method when you have class imbalances. It's very important, but this all of this is not mentioned in the chapter in itself in the book. So this is done by a previous cohort for you know, a personal understanding of the chapter.
Yeah, that's quite useful. Sorry, to be
Yeah.
clear, what it is something that I do because I realize it's very important for these rare classes, but it's something I've been doing sort of semi-manually until now, like kind of assigning the for example, cases and controls to different groups. So being able to do it this way looks easier. So I'll be glad to do it this way. I'll have a look into that kind of more extreme than 10% thing, because that kind of looks interesting to me and I'd like to understand why.
Okay, basically under some condition, you can use this 10% and assign into a validation set. So basically, you have your 80% of training data where you work out your model, and then you first test it on a validation set, which is smaller, like about 10% or something like that. And then you finally, when you agree, you finally test it on the testing set. And the validation set is something that is not frequently used, but it can turn out to be very useful somehow, especially when you apply some techniques that require, such as cross-validation, for example. We will talk about that in the following chapters. And there it will be mentioned about, more specifically, about the validation set, which is a reduced amount of data that it would be previously tested before the final testing set, basically. Olafemi.
Yes, thank you very much. But my own concern, I still want to go back because when you introduced, you said we use the initial split, then we specify the proportion should be maybe 70 or 80% for the training sets, then the others for the test sets. So I want to say that, is it ideal? What about if I said, okay, I want to use 60 or 65% of my data for the training, then the other proportion should be used for the test sets. And also when we're talking about the class imbalance, you use the strata. So I would like to know, how reliable are we to be sure that, okay, when we use a certain strata to check for class imbalance, that we are more, is it ideal, more reliable?
Okay, can you hear me?
Yes, yes.
Okay.
So I'm now twice, because I'm going to change the device. Okay. So what's happened basically, Olafemi, is this, that it's a great question about what, how can you hear me fine?
Yes, I can hear you.
Okay, now it's better. So basically what's happened is that, can you hear me? Yeah?
Yeah, we hear you well. Yeah.
Okay, great. So basically what's happened is that you can usually, if it's so it's suggested to use 80-20 for a reason, which is the consequence of using too much data for testing and too little data for training the model, which is the cause of bias and overfitting. If you you have new data, usually this new data might be very, so if you use too much of new data for testing your model, so you have already a certain number of observations, and your model can result very good, and instead it is not. So it might be difficult with little information to find a perfect model, but you can get very close to it. So, and then you will be certain that you are doing a good job. If you use a larger testing set, this might confound the result. I don't know if anyone else would like to add maybe more insights about these proportions. maybe with personal experience or something like that, something that can be useful. So the other question, what was the other question, Olafemi?
It's about, I think, the stratification. When we use strata, I was like asking how reliable, when we use the strata, how reliable, because we are using it to check for class imbalance. So I was like asking how reliable is that method?
That is as well very useful, but you apply when you have class imbalances. So usually you just apply, you use the response variable, but in extreme, when you do research, it might be possible that you have a response variable and then you ask for a stratification onto another predictor, for example. So it's depending on the type of research that you are doing, and it's very useful when you the first things that you do, you make a visualization, and such as scatter plot or an histogram or a simple bar plot, and then you immediately identify the imbalances if it's the case, and then you apply the stratification. That is something that you are required to do. While if it's not, there is no clear imbalance, you can not apply the stratification basically. This is what I was mentioning. So in the MS data, for example, the sales price can be very imbalanced. So it's important in this case to stratify. And
I have a question regarding this. So on the first example in the climbing data set, the strata was a categorical variable, and here it was a numeric variable. So does it make any difference, or we just use it just like it just works, or what do you know?
Yeah, it just works.
Okay.
Yes, just works. Just works. Obviously, they are numeric, but they group it somehow, so they're not very all different. Okay, so they are. There are some. So in this case, but you can. It just works. So you can just use it on text. And then here we have another example, which is very interesting. Initial time split. This is another function. Sorry, Freya, I forgot to tell you that you can split the data with Cohort as well. So with tidy models, it's quite straightforward because you do initial split and then you provide the data. But as well, you can do it with Cohort, and that was
Great, thank you.
Oh. When time data, we can use this initial time split because times as well as spatial data, when we do like longitude and latitude and informations.
I think Federica is, I'm not sure if it's only in my working station, but I experienced like you were like lagging on and off. I'm not sure if it's only, yeah, Freya is also supporting this.
Okay.
Okay. So now it's fine, I think.
Okay. So the
Oh, it started again.
It's sort of cutting out a bit, isn't it?
Yeah.
okay. Okay. So I'll stop sharing
Okay.
because my computer, I think, is
I think Federica, I think our phone isn't as reliable as our laptop, I guess.
Maybe not.
Yeah. Federica, we're having you like constantly on and off.
okay. What about now?
It's like a little bit jerky, I think. Now it looks fine, but I think like the moment you start speaking, it's like maybe overloading.
Now, really, I've switched off the computer.
Okay, now, yeah, we can try this, I guess.
Okay, so we haven't got much. Okay, now I'm sharing again the few things that we will be talking about. But basically, as we said, there are other functions such as initial time split, or that are for time data, or others for spatial data that require a special type of splitting. So this initial time split is one of those. And then you can use that when you are dealing with time series, for example. Okay, so I don't know if I'm able to share.
Maybe I can share from my own end so that you present from here.
Yeah, that's great. Thank you. That would be great. Yes. We left a very little bit of the rest of the chapter, and another case which is mentioned, and then here it's when we are in case of multi-level data. So in this case, this is 5.6. Yes, thank you. So in this case, it's important that to identify the independent experimental unit in our data. And this is, for example, when we got the MS data, you can see that we have one row per house. And so the houses and their property are considered to be independent of one another. So the very different specification of an house doesn't belong to a specification of another house. But in other data set, this might not be the same thing. So there might be multiple rows per experimental units. So such as in patients who are measured multiple times across time, and so on. So in these cases, to avoid data from the same experimental unit, beginning both the training and the test set, it would be useful to split along the independent experimental units, such as, for example, the X% of experimental units are in the training set and the other one in the testing set. So let's go into practice and see. Here is a data set which is from again the previous cohort, but it's worth to have a look at it, because here we have variables such as child, the age, the age, the measurement, and the season. Okay, so this is, for example, a data set. In case that we want to look at the child ID, because this might be repeating itself. So you see the number 1 is replicating itself a certain number of times, because the child has been measured along the seasons more than once. And so if we group it and then we split, it's like just as the same as we did a stratification on child ID. Okay, but we can do this in case of multi-level data. So because we are not predicting child ID, we don't want to use child ID as a response variable, but we can group it and then split it. It's basically the same as you stratify. And so again, what proportion should be used? Generally, as we said, this is comes to Andy very frequently. And if we go, there are mentioned some, you know, other important things, but I don't think it's now to expand, because it's my takes a bit of time, and as well as cross-validation. So basically what's happened, that if I change this proportion, within this range can be quite reasonable. Otherwise, so you arise in overfitting, or so not very good estimation, basically. Because or you have too much testing data, or you have too little for trusting your model result, basically. And this is it. So in conclusion, data splitting is an important part of modeling workflow, as it impacts model validity and performance. The most common splitting technique is random splitting. And to summarize the data, we say that some data, such as time series or multi-level data, require different data splitting techniques, and this is called stratified sampling. So we split the data, and then when it's needed, we apply stratification. And so the R sample package is the one that is used within tidy models, but if you don't use tidy model, you can load just R sample and use the function, for example. So in chapter 10, it is worth to mention, we will go back to those things, in particular looking at certain issues caused by class imbalances, and we will see some special function for to use for feature engineering the predictors, well, before modeling. So we basically split the data, but then we might filter and look at the engineering predictors to cover some class imbalances. So we go back to those things in chapter 9. In chapter 10, looking at class imbalances, bias, and overfitting. Okay. Thank you, Olafemi. You can stop sharing.
Thank you very much, Federica. Yeah, go ahead. You started saying something.
just if you have any questions, I don't know if I can help.
Yeah, so I just it's just like on a side note, like Freya, regarding what you said about the janitor package, I wanted to recommend like the table function. I'm not sure how familiar with it, but it also has like a two-way table where you can have like counts of like it's like the base R table function. And then you can have like counts on how many observations you have on intersections of each pair of on pairs of variables. So for me, it's like a very common. I use it like on a almost daily, not daily, but it's on a regular basis. And also just a very side note that I started contributing to the janitor package recently, so it's really nice. Yeah.
Yeah, that's now part of the. Is that part? It's not part of the tidyverse?
No, it's not part of the tidyverse, but it shares like some of the design concepts.
Yeah, I use it for quite often as well for cleaning clean names.
Yeah.
Yeah, it's quite automatically. But yes, this table how do you pronounce it?
I think it's pronounced tabil, but I'm not like table, but I'm not sure.
It's very useful. I've tried to use the table function from base R, but then at the end I never use. I use count, so for me it's quite useful to use count. If I use count, I have the same result.
Yeah, but then again, if you have two variables, then count, like it has like a different format. And when you do like a two-way table, then you have like the top row is like the values of one variable, and the leftmost column is like the values of the other variable. So visually, sometimes it's easier than the count by two variables.
Looks like you kind of classic contingency table. That looks really handy.
Yeah, and even the schema package is it's very useful. What I don't like is that it's too much, so it's too long. So yeah, you can like use it, have a look, but you can hardly include it in a summary or something, because it's very invasive. I prefer like glimpse or structure or something like that. And then I have a look at the schema because it gives me information about the empty
like
cells.
missing values.
Yeah, not only missing values, because there are empty cells, empty, with no values inside. Some are not considered missing values. So if you have empty observation, they might escape so they're not considered missing values. So this is useful because you can see the empty thing, if there's any.
And I guess also the unique statistic is also very useful, which I always have to like wrangle to get it, and here it's just like out of the box. So yeah, very interesting. Personally, I have to go now. So again, I just wanted to thank you, Federica.
Oh, thank you too. That's okay, thank you.
Okay, so
all right. You too.
Bye.
Okay, thank you. Bye.
Sorry, who is this? Who is the next one? Who is doing the chapter next week?
I'm doing the chapter next week.
Okay, great. Okay, so Olafemi next week,
Yes,
chapter
yes.
6.
yes.
Okay. Have you got any other questions?
No, I don't have
Maybe.
any.
Okay, I'll see you next week.
Yes.
See you next
Bye.
week.
Bye.
Bye bye.